Welcome to this first Advanet webinar. First of all, this webinar is going to be in English language, but the slides have also the Japanese translation. You can make questions just by clicking on the right button in the message button, and we will answer you via email in the next coming days. We are planning to hold other webinars in the next weeks, so please stay tuned and follow us on social media. You can find us on Twitter. You can see our two accounts here. First one is Advanet Japan. Second one is Advanet IoT. You can also find us on Facebook, Advanet Japan, or you can subscribe to our newsletter. You can also find all the information in our website, www.advanet.co.jp. So the agenda for today is the following. I will briefly introduce who we are and what we do, followed by a quick overview of our IoT solution, which is called Everywhere IoT. Then I will show you a demo, a live demo, when you will see how convenient it is to connect our IoT solution to a typical industrial machine, such as a PLC. So very briefly, who we are. Advanet is a company created in 1981 in Okayama, where we still have our headquarters and our factory. We also have a Tokyo office. Advanet is a technology provider specialized in high-performance embedded computers, with the unique advantage to have our own factory. So we are not able only to apply our R&D skills in design and testing, but we also physically make them, which puts us in the perfect position to fully help our customers in every step. Since 2007, Advanet became member of a group called Eurotech, which is a company based in north of Italy and specialized in embedded systems and IoT. Very briefly about Eurotech. Eurotech is a company which vision has always been that to bring more computing capabilities near to the end user or systems, which technically is translated in trying to make the high performance computers smaller and smaller in order to fit in every system under every condition. Eurotech has been one of the first companies to introduce the idea of M2M, or machine to machine, which then shifted to what is now IoT, Internet of Things. Eurotech, together with IDM, is the creator of the MQTT protocol, which then has been donated to the Oasis Foundation and made it open source and available to everyone. Now MQTT is the de facto standard protocol for IoT worldwide. Eurotech portfolio includes also an IoT platform based on open source, which is the scope of the second part of this webinar. Still few words about the Eurotech group. We are basically present worldwide. We are here, as I said, in Japan, in Tokyo and Okayama. The headquarters is in Italy, but we are also located in France, UK, and United States. What makes really unique our group is the product portfolio. With Advanet expertise in boards and modules and high performance embedded systems, and Eurotech history in subsystems, intelligent sensors, and IoT, the Eurotech group is able to cover the entire spectrum of needs for all those customers who are interested to miniaturized and connected high-performance computing systems. We cover basically the full stack of IoT, from the pure hardware to the cloud. And you can see in these slides some example of our product categories. Together, Advanet and Eurotech make 40 years of experience and expertise in miniaturized high-performance computing, where energy efficiency is one of the key factors. All these makes a unique value proposition by the Eurotech Group. We have products that span from high technology certified modular and IoT ready products to competencies where we specialize in customization in order to fit with any kind of needs in terms of conditions and resources, to services where we are experts in following the customers in the whole process, from requirements analysis to professional services post-sales. The verticals we address are various. We have successful use cases in all these ones, from industrial and automation, transportation and mobility, energy, defense, and healthcare. We will cover some of them in the next webinar, so please follow us. We work with a lot of important customers all over the world, from Japan to United States. You may know some of these ones. We also work with a lot of partners who integrate our solution in order to give as much value as we can to all our customers worldwide. The unique value proposition and skills of the Eurotech Group has been awarded several times over the past years, both in IoT and embedded systems. But now let's jump to the second part of this webinar, IoT Everywhere solution, which is composed by two parts. First one is Everyware Software Framework, or we call it ESF, which is the software on the edge that runs by default on all the edge devices provided by Eurotech Group. Second one is Everywhere Cloud, our cloud solution that allows you to make device management from remote, and not only. We'll see now in the demo, see later in the demo. So let's jump to the second part. Let me take the presentation. First of all, to give the context of our IoT solution, first of all, there are some imperative needs the IoT nowadays is asked to solve. The first one is the need of connectivity between machines and with external networks and with a variety of different communication protocols. The second one is the need of computational power in energy-constrained devices, where conditions can be tough, such as extreme heat, cold, shaking. The connection can be weak. The devices need to be ruggedized, for example. These devices are not only expected to work smoothly, but also for a long time and with the least maintenance possible. They are also required to have enough computational power to run algorithms such as machine learning, deep learning, with the lowest latency possible. The third one is integration, which is very important. Integration with existing customers' assets, systems, and analytics. Reducing the gap between operations and IT is one of the biggest advantages expected from an IT system. The fourth, but absolutely not least, is security. Nowadays, a very hot topic, and it always has been a hot topic. And security for Everywhere IoT is one of the key factors. IoT is expected to basically fulfill all these needs. But of course, there are challenges. The first challenge is the lack of open standards. There is a variety of technologies out there, variety of technologies and protocols to achieve basically the same goal. A lot of companies reinvent the wheels to provide the best protocol, while, for example, there are other similar ones. These create the following other two challenges that you can see in the slide, such as vendor lock-in, which means that once you select a vendor, you're stuck with it, since changing provider will be very complicated, and fragmentation with the imperative need to integrate with systems, and so increasing the already high complexity. Everywhere IoT offers a solution to this challenge, to these challenges. First of all, is open and interoperable. We're based on open source, and this core software reduces the risk of vendor lock-in. This leads to open integration with application and much lower implementation costs. Then it's integrated and modular. We offer everything needed to get data to the cloud for fast and time to revenue. We offer flexibility to choose the IoT stack components you want. We offer a solution that doesn't force you to use an end-to-end Eurotech only solution, but we have plenty of possibilities to easily integrate with other systems in every layer of our IoT stack, in the IoT stack. And then it's managed and secure. We provide strong protection against unauthorized access and data snooping. We provide remote software updates and batch distribution to the edge devices. And we provide also digital twins in cloud that simplifies management of distributed assets. This is a graph representation of Everywhere IoT. We provide all the components needed to create an entire IoT stack. The hardware with industrial-grade IoT gateways capable to connect to a big variety of communication protocols for every step of application, every type of application and data acquisition. The edge software inside the gateway, called Everywhere Software Framework, which allows to easily connect industrial machines to the cloud, visually create data flows on the edge, and route data to other systems for doing data analysis. The communication protocol we use by default is MQTT. And then we have the cloud platform called Everywhere Cloud, which allows to secure, collect, and store data, remote management of the edge devices, and this integration with external systems. Each of them can be seen as separate components. Eurotech Group provides the edge part composed by sensors and edge devices, and the cloud part needed for the device management. But each part can be also used singularly and mix it together with other solutions from other vendors at any level. We already work with many customers and partners in order to provide different solutions to address different needs. As I said, we are strong believers and supporters of open source. The core of our software solution is completely open source. ESF and EC are two projects belonging to the Eclipse Foundation, and the Eclipse IoT project in particular. ESF is based on Eclipse Cura, and EC is based on Eclipse Capua. These two projects have been started by Eurotech a few years ago and donated to the Eclipse Foundation. In the Eclipse IoT project, Eurotech is one of the founding members, and we work very closely with other big companies such as Red Hat, Bosch, Microsoft, etc. You can see here in the slide. It is a very big project where we are one of the biggest maintainers. But now let's jump briefly in each step, in each layer of our IoT solution. First one is the hardware. We provide a wide range of IoT gateways, mostly separated in three categories: multipurpose, transportations, and rolling stocks and edge servers. In each category, we have also different models to meet different computational capabilities. So based on different chip architectures. You can see here, some of them are RAM, some of them are Intel. For our daemon in particular, we're going to use the Relia Gate 1011. Now let's jump to the Edge software, Everywhere Software Framework. Everywhere Software Framework is a Java application. We recently switched from Java Oracle 8 to Zulu Embedded Java 8 provided by Azul. It is an application based on an OSGI architecture, which allows an orchestrated and modular architecture that is easy to maintain and extend. Can be run on Linux, can be run also in Windows and in Docker containers. ESF allows to connect to a variety of the most common industrial communication protocols, such as Modbus, Profinet, OPC UA, or S7, and physical protocols such as Bluetooth, CAN bus, GPIO, serial, Wi-Fi, Ethernet, etc. ESF allows also an easy computation on the edge. It contains a light database, it provides APIs, and an easy to use visual programming tool called Wires, which is this part here that you can see in the middle of the slide. But you will see it better in the demo in a few moments. ESF allows to connect to all the cloud providers of your choice and also to other systems, thanks to an easy data routing, for example, with Apache Camel or Kafka, and device management through digital twins from Everywhere Cloud or other systems, such as Azure IoT, for example. ESF provides, by default, an easy connection with a lot of different field protocols. The ones that you can see here in the slides, the first line here are the ones that we already support by default. Other ones, which are already many protocols, other ones are under development. So we basically already cover by default all the most common communication protocols that you can find in an industrial setting. Integration of ESF with other external systems on the edge is easy and enabled using different ways, such as REST APIs, messaging. ESF contains also its own MQTT broker and JDBC connection. The remote management of the devices is done through Everywhere Cloud or Eclipse CUDA. ESF and its open source version, Eclipse CUDA, is provided by default with all the Eurotech Edge devices, and it can be easily installed on open hardware, such as Raspberry Pi, for example. In fact, many customers try Eclipse CUDA before using ESF on their own hardware, and they decide then to go for the enterprise solution. And this is a very convenient way to allow customers to rapidly create a prototype, and so to be fast and to create a prototype to have a quick time to market. As said, ESF is the enterprise version of Eclipse Cura, but we provide a lot more features, such as basically the typical ones which are essential for any enterprise IoT solution in terms of security, efficiency, customization. Now let's go to Everyware Cloud, our cloud platform that allows remote management of the connected asset, secure connectivity, and storage. Everywhere Cloud is a set of Docker images, which means that it can be deployed everywhere you need, on-premise or in the cloud, or also as a service. The only thing it needs is Docker orchestrator. We suggest Red Hat OpenShift, but it can also be installed in Kubernetes, for example. As said, Eclipse Cura is EEC is the enterprise version of Eclipse Cura. We provide basically, as I said, for ESF, the most important features which are essential for an enterprise IoT solution. Everywhere Cloud provides everything that is needed for remote management, such as VPN connection, provisioning, software updates on the air. It also provides data management, such as storage and data access. It can be very easily integrated with other systems through REST API or WebSockets or other means. An essential part is security, as I said at the beginning. This has been the focus of Eurotech since the creation of the platform. We provide security end-to-end from the hardware side, where, for example, we use modules such as TPM, where we do encryption of configuration and storage. The applications inside ESF, for example, are signed and the device is uniquely identified. We then, of course, use security in communication protocols, for example, using SSL or TLS. All the messages sent are signed, and we also provide, for example, mutual authentication. We then have cloud security with, for example, features like two-factor authentication, role-based access control, certification management, and server identity management. On top of this, on top of all these technical features for security, we also very regularly, very frequently, ask external specialized security companies to perform penetration testing and vulnerability assessment. So that's it for the overview of Everyware IoT. Now I think we can jump to the demo. Let me share my web here. And let me share a presentation where I briefly explain the architecture of the demo. The configuration of the demo is the following. I have here in my desk, what you can see in the webcam, an IoT development kit. This development kit is composed by 3 items. The first one is the common industrial PLC, here you can see on the right in the webcam. Then we have an input-output board with some LEDs and toggles that can be connected, that is connected to the PLC channels, as you can see in the webcam here. And then we have an IoT gateway. In this demo, I have an Eurotech RelayGate 1011, which is this one, which is a multi-purpose gateway. The gateway is connected through Ethernet to Everyware Cloud. In this demo, I want to use the RelayGate to manage the PLC in order to switch on and off the LEDs and toggles in the board. The Relay gate will send the status of the LED and toggles from the PLC to Everywhere Cloud, where the data are securely stored. Once the data are on Everywhere Cloud, a web application that we made will use the REST APIs provided by Everywhere Cloud in order to create a digital twin of the PLC, so that I will be able to manage from the web application the PLC itself. Now, let me share my screen. This will take a few seconds. Sorry about that. Okay, so that is it. What you can see here is the UI of Everywhere Software Framework, which is the software installed inside the gateway. Now, I'm connected with my laptop to the gateway through an Ethernet cable, so I can reach the ESF UI with a web browser. ESF, as I said, is an edge software that allows you to completely manage via UI all the configuration of the edge device. In this case, the Relay Gate 1011. But very quickly, let's see the main menus provided by ESF. Here, you can see the status. So here you can see basically all the information about the connections currently used and the information about the cloud account that I'm connected to. In this case, I'm connected to the cloud, Everywhere Cloud, to the sandbox I'm using for this demo. And here you can see some information about the connections interfaces that this gateway provides. In this case, I have Ethernet and wireless. There is also the GPS, but now it's disabled. Then, if you go to device, you can see all the information about the device itself, information, hardware, and software. As for example, you can see information about the version of ESF running inside this gateway, information about the hardware, information about the firmware, the JDK, the Java virtual machine installed inside the gateway. But you can also do some interesting operation directly from the UI. As I said, ESF is created using OSGI and OSGI architecture. And here you can decide to stop and start some of the modules of the OSGI. If you want, you can also run some Linux commands inside the device itself directly from the UI. Then, of course, the ESF provides also network management, where you can set and configure all the interfaces, the connection interfaces of the device. An important feature is firewall. We provide a firewall where you can basically open, close doors in the connection. You can do port forwarding or masquerading. And then cloud connection. In this case, as I said, I'm connected to Everywhere Cloud, but you can also connect to every other cloud provider of your choice, and you can set here all the information for the connection. Now let's jump to the demo. Let's see what I have done for this demo. So first of all, in order to read data from a PLC, we have to be able to read data from the Modbus protocol. In order to do this, an operating system requires a Modbus driver. The Modbus driver for ESF and Eclipse Cura is one of the plugins which have been developed by Eurotech. So if you want to install the driver for the Modbus protocol, it's very easy. You can just go to Packages in ESF and do Install. So as you can see, I already installed the driver for the Modbus. The installation is very easy. Either you have the plugin in your laptop, so you can just choose the file from your file system, or you can put the URL of the plugin in case the plugin is installed somewhere else in the cloud, for example. You can also do drag and drop from the Eclipse Marketplace directly through here. Now, once the driver is installed here in ESF, then you have to make it available for ESF itself. So let's jump to drivers and assets. We have two concepts here. The first one is driver, which is the normal driver that we are used to, the one that we just installed. And if you click here, you can configure the entire driver. You can select the Modbus connection access, for example. I'm using RTU, where you can set on TCP or UDP, for example. You can set the IP address of the machine connected. In this case, it's a localhost. It's in the same board. And you can set the port. You can set the rate. You can basically set all the standard configurations of the Modbus protocol. Then we have the concept of asset. While the driver is the physical driver that you need to read data from the communication protocol, the asset is a logical representation of the driver itself. In the asset, you can decide what you want to read from the Modbus protocol. So you can select, you can configure the channels of the Modbus protocol. In a standard Modbus protocol, you have different channels, coils, discrete inputs, holding registers, input registers. In this case, for this demo, the PLC provides a lot of channels, so I want to read from all of them. And I have configured all the channels here using the asset in ESF. And you can see also the value of the channels in real time here. But now that you have driver and asset, a very cool features of ESF is the possibility to create a visual application flow without having any coding skills. You can do this with a wide graph. So in this demo, I want to read every 2 seconds from the Modbus, from the PLC. How you can do this? In the wire graph, we provide some wire components. One of these is a timer. I set a timer component that I set to 2 seconds. And every 2 seconds, I'm asking to the PLC So I'm reading the data from the Modbus asset, which is the asset that I configured before. Every 2 seconds, I want to read the data from these channels. Once I read the data, I want to send them to the cloud or to an internal file logger inside the gateway. As you can see, I have basically created an application flow without knowing anything about programming. So this is very convenient. Now, let's jump to Everywhere Cloud now. Let me refresh. So I can log in again. So as I said, I'm using our sandbox at the moment. This is the interface, the UI of Everywhere Cloud. You have basically all settings that allowed you to read data and configure the device, the edge devices. For example, now here in the device, you can see my gateway connected, the ReliaGate 1011. A very interesting feature is that here you can see all the information of the gateway. If you go to configuration, you can see the configuration of the device here on the cloud. So basically everything that you see here in ESF, all the configuration that you have done are available here on Everywhere Cloud. Also, the Modbus asset and driver. This Modbus asset here is a representation of digital twin. If you modify the value here of this configuration, you will be able to change the value of the PLC itself. Now, I can do this here, or you can do this through the REST API, which is my scope of this demo. As I said, I'm sending the data to Everywhere Cloud, so you can find the data here. These are the namespaces of MQTT that I created. If, for example, you choose the toggle information, you will see the value in the MQTT of the toggles in the board. Now that the data are available here, I want to use them through the REST API. So let's jump to the web application that we created. This is basically a digital twin of the PLC, of the board that you can see here in the webcam. Now, if I click on LED one, you'll see the LED one in the webcam here, switching on. You can do this with all the LEDs, you can turn them off, you can change the color of this one, you can make it red. I can also change it from here. So if I click on this, you can see that now in the web application, it becomes green. I can switch it off. Let's see what's happening in the ESF now. So if I change the data from the cloud, I should be able to see the data changing also here. As you can see, the LED 2 now here in the physical board, it's true, while the other ones are false. What if I switch it off again? And here I do refresh. Then it becomes false. So with this demo, I wanted to show you how convenient it is to connect and easy it is to manage and configure a physical asset through digital twins using Everyware software framework and Everyware Cloud. Now, this demo is completed. It's very simple. In 5 minutes, you can be able to connect your industrial machine to a gateway and send the data to a cloud. Really takes 5 minutes. Now, let's imagine that this was a proof of concept. You just have found the right configuration for just one single device, but now you want to deploy this to a number of gateways because you have hundreds of PLC, for example. Without an IoT system like Everywhere IoT, you should physically go to every gateway, connect to each of them, and make manually the same configuration. Everywhere Cloud allows you to automatically do this from remote, from a number of devices all together in the same time. You can do this in Everywhere Cloud. You can. The first thing is to save the configuration of the device. In Everywhere Software Framework, you can go to Settings. And as you can see here, there are some snapshots. The snapshots are the current configuration of the edge device. As you can see here, there is the history of snapshots. So you can also roll back to an old one in case something gets wrong with the device. But if this one, the current one, is okay, and you want to deploy it in your factory, the first thing is to download it. Now I'm not downloading it, but as you can see, it's an XML file. Then you go to Everywhere Cloud. Here, for example, you would have a number of gateways connected. You go to Device Jobs. You can create a new job, so you can select all the gateways, for example. In this case, I have only one gateway, but you could have hundreds of gateways here. You can also select the gateway with tags for convenience. And then you can perform an action to these gateways. For example, I want to configure update the configuration. And here you can select the file that I just downloaded from ESF. When you do submit, the file will be uploaded to all those gateways in the list automatically. You can also schedule some actions in case, for example, you want to perform some actions regularly. So that's it for the webinar. As you can see, it's very convenient to connect an industrial machine with Everywhere Software Framework and Everywhere Cloud. If you have any question, please don't hesitate to leave a message in the box on the right. We're going to perform other webinars in the next weeks, so please follow us. I hope you enjoyed this webinar. I hope you understood more or less the high-level features of Everywhere Cloud and Everywhere Software Framework, which is the IoT solution provided by the Eurotech Group. Thank you for listening, and see you in the next webinar.